Hello, welcome to the differentiation topic on A2 Maths. We're going to look at the product rule and quotient rule. But before that, I want to introduce these new functions, and then we're going to have a look at how to differentiate these functions. That'll be about 2 minutes in, and the actual product rule and quotient rule will be about 3 minutes in. So, first off, e to the power x. Now, you already met functions like 2 to the power x. This is e to the power x. E is a number, a bit like pi. It's not a fraction, certainly, and so a function y equals e to the x is going to look a bit like any other function that says a number to the power x. ln x is just log to the base e of x. So you've met log to the base 2 of something and log to the base 10. This is log to the base e of x. They're important, by the way. They link together. So just like you can undo 2 to the power x with log to the base 2, you can undo e to the power x with ln x. So those two are actually inverse functions. Okay. Now we've got some new trigonometrical functions for you. We've got sec x, which is 1 over cos x, and cosec x, which is 1 over sin x, and cot x, which is 1 over tan x. But that's probably more useful to think of as cos x over sin x, so the other way up from tan x. Now the best way of remembering which one's which is the third letter rule. So sec x, third letter c, is 1 over cos x. Cosec x, third letter of cosec is s, that's 1 over sin x. And cot x is 1 over tan x. So the third letter of the new function gives you the first letter of the old function that you're dividing by. Let's have a look how to differentiate e, ln, sin, cos and tan. So e to the x, when you differentiate it, nothing changes, you just get e to the power x back. When you differentiate ln x, you get 1 over x. When you differentiate sin x, you get cos x. When you differentiate cos x, you get minus sin x. And then when you differentiate minus sin x, you get minus cos x back. And then when you differentiate minus cos x, you get sin x. So this goes round in a cycle, a square cycle. That's why we call it the differentiation squircle. And finally, when you differentiate tan x, you get sec squared x. So you'll need to memorize all of those. Right, now we're at the actual product rule bit, the bit that you've been waiting for. The quotient rule bit will be about 11 minutes in. So let's have a look first at the product rule for differentiating products. A product is where you have two things multiplied together, so let's start with a couple of functions that you're more used to differentiating. So let's have a little pretend go at this. If you differentiate x cubed and x squared, you get 3x squared when you differentiate x cubed, you get 2x when you differentiate x squared, and when you multiply those together you get 6x cubed. But that can't be right. This is x to the power 5. We should here have 5x to the 4, so this is just crazy wrong. So if it was x cubed plus x squared, that would be fine. You could differentiate those separately and you'd get the right answer. But hopefully you learned on core 2 that if you have two things, you have to multiply out before you differentiate. Same thing if you've got two things that you're dividing by, you have to divide through. But there might be a bit of a problem if you can't. If this was sin x and this was cos x, you can't multiply that out. So we need some way of finding what the rule is for when you multiply two things, when you differentiate two things that are multiplied, and it's not just differentiate them both. That clearly doesn't work, gives you crazy answers. Okay, so here's the truth of the matter. This is the product rule. This is your first genuinely core 3 differentiation fact. When you have two things multiplied together, we're calling them u and v here. So in the example we had, u was, oh, I've forgotten, u was x cubed and v was x squared. So you've got these two things multiplied together. When you differentiate them, you get v, the second one, times u dashed, that's short for differentiate u, plus u, the first one, times v dashed, which is what you get when you differentiate the second one. Okay, so you might want to differentiate, remember that as vuv. So when you differentiate a product, you get vuv, and we've got an apostrophe on the second one, meaning that you differentiate this one and you differentiate that one. You can write this out with v du by dx plus u dv by dx, but it's easier and quicker if you use the dashes, in my opinion. Okay, so how do we actually end up using that? Let's use this example. We'll use the product rule on it properly. So we've got y equals x cubed and x squared, and let's find out what dy by dx using the chain rule. So the first thing to do is to write down the product rule. Dy by dx is v u dashed plus u v dashed. It's always worth writing down any rules that you're using every time you use them, because it really helps you remember them without you having to try, and it might get you a method mark. So u is x cubed and v is x squared here. So u dash, when we differentiate that, we just get 3x squared, and v dashed, when we differentiate that, just gives us 2x. So that means that dy by dx equals, so I've got vu dashed, so that's v x squared, times u dashed, which is 3x squared, plus uv dashed, so there's u x cubed, times v dashed, which is 2x. So that comes out as this bit, I've got x to the power 4, and there's 3 of them. And here I've got x to the power 4 again, and there's 2 of them. And when you add those together, you get 5x to the power 4. That's good news, because we were differentiating x to the power 5, and we turn out to have got 5x to the power 4. So this time we get the right answer. Okay, let's have a look at another example. This is much more like the sorts of examples that you'll actually get. There was no need with that example that we looked at to use the product rule. Much more simple to multiply that out. Okay, so if these are polynomials, it's really worth multiplying them out, unless that would take you ages. So here let's have a look at x squared times sine x. Okay, I think you should pause here and have a go yourself. You need to write down what the product rule is. You need to write down what u is, what v is. You need to write down u dashed and v dashed and plug them in the formula. Have a go, press pause. Okay, the first thing you should have written was the chain rule, v u dashed plus u v dashed, and that u is x squared and v is sine x. When you differentiate those, you get u dashed is 2x and v dashed is cos x. And then when you sub those into the formula, it turns out that dy by dx vu dashed is sine x times 2x. And we normally write a 2x in front of a sine x, so you don't need any brackets or multiplication signs or anything. And uv dashed is x squared times cos x. Okay. Okay, it's time for you to practice now. Have a go at these 5. Make sure you've written down the product rule. Make sure you write down what u, v, u dashed and v dashed are. Show you're working clearly, and then check your answers afterwards. You need to press pause now so that you can work on those. Here come the answers. The first one, cos squared x minus sine squared x, or cos x minus sine x sine x. The second one, ln x plus 1. I hope you simplified that down a little bit. And then the third one, I've written as 2x plus x squared in brackets times e to the x. But you probably wrote something like 2x e to the x plus x squared e to the x, which is also fine. It'll turn out later, when we're using this, that if you're finding a stationary point, you want to solve dy by dx equals 0. And it's much easier to solve that sort of problem factorised rather than just written out. Okay, the fourth one comes out as 7x to the 6 cos x minus x to the 7 sin x. And the fifth one comes out as cos x plus sin x, all in brackets, times e to the x, or as you probably wrote it, cos x e to the x plus sin x e to the x. Okay, if your reaction to those was, yes, I'm sure I'd have got those, you're deluding yourself, go away and practice. No one gets good at doing the high jump by watching other people do it, and no one gets good at maths by watching other people do it. So go away and actually practice those and come back and check whether you actually got the right answers. If you made a couple of mistakes, why not press pause, go back and see if you can dig out why it went wrong and where it went wrong. If you made a lot of mistakes, perhaps you better go back and watch me doing the previous ones. Okay, that's it for the product rule just now. We'll be moving on to the quotient rule next. Now we're at quotient rule, so we're about to find out how to differentiate fractions of functions. Quotient is an old-fashioned name for fraction. You could say the quotient of 3 and 4 to mean 3/4. Anyway, so a quotient of functions means one function on top of another one. Okay, let's do it the wrong way first. X cubed over x squared. So differentiate the top, get 3x squared. Differentiate the bottom, 2x. That cancels down because there's an x on the bottom. 3x over 2, nonsense. Complete nonsense. This simplifies down to x, so when you differentiate it, you should have got 1. Okay, so you can't just differentiate the top and the bottom and divide them. That just doesn't work. What's the way that you actually do it? It's the quotient rule. Okay, so when you've got y is a fraction u over v, or a quotient u over v, dy by dx is vu dashed minus uv dashed over v squared. So there's that v thing again, but there's a minus in the middle, and there's a v squared on the bottom. Okay, so that's another one that you need to memorize. It's not in any of the formula booklets, so you just have to memorize it. Let's use that on our example next. So the first thing we should do is write out the quotient rule. This time with the minus. vu minus uv dash. vu dash, sorry, minus uv dash over v squared. And then we need to actually differentiate all these things. So I've got a u which is the top of the function, so that's a u over v. So I've got u is x cubed, I've got v is x squared, then u dashed is 3x squared, and v dashed is 2x. So how do they fit in the formula? So vu dashed is x squared times 3x squared, so that's 3x to the 4, minus uv dashed, so that's this times this, so that's 2 times x to the 4, and all over v squared. V is x squared, so when I square that I get x to the 4. So the top simplifies to x to the 4, and the bottom is already x to the 4, so it all comes out as 1, which is what we should have got because x cubed over x squared is x. Okay, so that's it with, but again, we wouldn't really do that, we'd simplify the fraction first. So let's use it on a genuine example. Y equals tan x. Where's the fraction? Right, so tan x is sin x over cos x. So that's going to be our u over v. Why not have a go yourself? Pause it and then you can see how I do it. dy by dx equals, always write out your formula first, the uv over v squared with the minus in. So what are my u and my v and my u dash and my v dash? U is sin x and v equals cos x, which means that u dashed is cos x and v dashed is sin x. No, it's not, it's minus sin x. Oh, classic mistake. Minus sin x when you differentiate cos x. Okay, so how does that fit into the formula? Vu dashed, v times u dashed is just cos x, so that's cos squared x. And then I've got a minus, and then uv dashed, so that's sine x times minus sine x. So actually I've got minus sine squared x, but it's minus that, so that simplifies down into a plus. And then on the bottom of the fraction, v squared, and v was cos x, so I get cos squared x. Now, we can simplify that, so have a pause and a think about how you can simplify that, if you haven't done already. We can simplify it, actually we can simplify it two different ways. Alright, so let's have a look. First off, let's simplify the top of the fraction. Can you see that we've got cos squared x plus sine squared x? Well, you learnt in core 2 that that's just 1. So we've got 1 over cos squared x. Okay, we can write that a different way now that we've got our new functions. So that's going to be sec or cosec or cot. Which one is it? Well, the third letter has to be c, so that'll be sec. Sec. So 1 over cos x would be sec x, but this is 1 over cos x times 1 over cos x, so it's sec squared x. Okay, so that's one way of simplifying it. Another way of simplifying it is thinking, well, this is a fraction, and so I can split it into two, you know, a bit like 2/5 plus 8/5. I can separate. So that's equal to cos squared x over cos squared x plus sine squared x over cos squared x. And that left-hand side is just 1, and this right-hand bit is sine squared x over cos x. Sine x over cos x is tan x, so that's tan x squared, which is written tan squared x. There we are. Well, we simplified it two different ways, and we've got two different answers. Did we make a mistake? Not at all. Okay, so here's a trig identity that you learn in the second year. 1 plus tan squared x equals sec squared x. Okay, the other one that you'll be learning is 1 plus cot squared x equals cosec squared x. And that comes out for very much the same sort of reason. Okay. Time for you now, have a go. So pause, work through them all, and come back in a minute and see what, well, a few minutes, and see what the answers are. So here come the answers. The first one, dy by dx. Hopefully you managed to simplify this down. You get minus cosec squared x, or minus 1 minus cot squared x. If you just change the sign on those answers, you can see the whole cosec squared x equals 1 plus cot squared x thing going on that I said would go on. Okay, and then for the second one, dy by dx is 1 minus ln x all over x squared. And the third one, 2x minus x squared over e to the x. Fourth one comes out as 7x to the 6 cos x plus x to the 7 sin x. And the fifth one, cos x minus sin x over e to the x. Okay, like before, if you looked at all those and said, I'm sure I'd have got that, go back and actually do them. If you made a couple of mistakes, go back and find them. And if you got them all right, well done. Okay. That's the end of the product rule and quotient rule video. So go away and practice on exam questions that tend to be a bit more complicated. You need to practice questions where they're asking you to find stationary points, questions where you use dy by dx, questions where they're finding the tangent or the normal to a curve. There's a lot more than just being able to differentiate that ends up in an exam question.